All right, so today we are going to continue solving trig equations. So on Friday last week, we started talking about it. We went through a few basic examples, 2 of them. But the one thing that I want you to remember is, again, that trig equations are periodic, right? That's one of their special properties. They repeat themselves. So solving trig equations is going to have more than one solution. And for our sine and cosine, what we do is we keep adding on one period, right? If we're talking about the unit circle, if I have one solution, right? If I have a solution here, and, whether it's either my x or my y coordinate that I'm looking at, if I do one full rotation, we end up back at that same spot. So if we're talking about radians, if I add 2 pi, I get the same answer. And if I keep adding 2 pi and 2 pi and 2 pi, those all give me solutions, right? So we have our general form, which is the original answer, and then we add 2 pi n, okay? And that is for sine, cosine, cosecant, and secant. For tangent and cotangent, our period is pi, so we just add pi n. And again, n is just a natural number. So, whole numbers, 1, 2, 3, 4, 5, 6. So that's again, these are known as, where do I have it? The general solution. Okay. So if they don't tell you, your answer will be in this window, then you need the general solution, which is the plus 2 pi n, or just the plus pi n. We'll get there eventually, but they may give you a window on where the answer is. We may not get to that today, though. We might have to wait till tomorrow. Yeah, okay. So let's take a look at some more examples of solving. So real quick, just to go over the ones we went over Friday, just as a recap, we follow the same rules of algebraic solving as, we normally do. But the only difference at the end is we use inverse trigonometry, or we use the unit circle to help us find our solution, right? So, we add and subtract from both sides. We divide when we have to, right? We're looking to isolate our variable, x or t or theta or whatever we have. Right. So if we have a squared, we might have to square root, right? If we see a tangent squared, a sine squared. So we have to remember, excuse me. Oh, that's a big one. To take these things into consideration. Right. So, because we have to do all that, we have to take other things into consideration too. So let's look at Nope, I wrote that. Okay, so we are going to start off looking at cotangent x plus cosine squared x equals 2 cotangent x. Right, and again, we want to solve this. Now, be careful. If they say verify, then that's when we have to go back and we have to do what we did last week, and we have to use our trig rules to make this side look like that side. Right, so I'd say, all right, let me take this side and let me break it down to sines and cosines and make it look like that side. Right, that's when it says verify. When it says solve, that means we want to get the x's alone. So here we have a few things going on because we have 2 trig functions, cotangent and cosine. So again, we're trying to eliminate things. We don't want, and now we can work on both sides of the equation. When we were doing verify, I only worked on one side and made it look like the other, right? But now I can work on both sides. So I have a cotangent x and cosine squared. They're being multiplied. And on this side, I have a cotangent. So I can't subtract. Okay, and I can't really divide by cotangent x. It doesn't work that way. That's the one drawback, right? I can't just divide by cotangent x and they're both gone. But what I can do is I can move everything to one side, right? That's part of the things that we try to do, is try to move all the variables, all the x's, to one side of the equation. So I'm going to subtract 2 cotangent x from both sides. Now, on this side, I can't combine these two because these two, this has a cotangent and a cosine, and this just has cotangent. So all I can do on the left side is just rewrite it as cotangent x cosine squared x minus 2 cotangent x. And then on the right side, because I removed everything that was there, I'm going to have a 0. So now looking at this, all right, again, there's no rules that I'm seeing right off the bat. I can replace this with a 1 minus sine squared, but that would just make things trickier because then I'd be dealing with sines and cotangents. But what I do notice is there's a cotangent in this first half and the cotangent in the second half. So we can factor that cotangent out. Okay, just like we factor with normal polynomials, okay, we can factor out trigonometry. So I pull out a cotangent x. What I'm left with is cosine squared x minus 2 equals 0. Now here, you might say, okay, well, that kind of looks like a Pythagorean identity, but this is a 2 and not a 1. Okay, if this was cosine squared x minus 1, then you can replace it with sine x squared. But again, that's not really going to help us. Here, though, I use my multiplying property of 0. Right? So if I was dealing with normal equations, this might look something like x times x minus 2 equals 0. If I have something like this, we split it up, right? That's one of our basic rules of solving quadratics. I'd have x equals 0, and I'd have x minus 2 equals 0, and I'd solve both of those. Well, we can do that with trigonometry. So my first one is cotangent of x equals 0. And then my second is cosine squared x minus 2 equals 0. All right, so now I have 2 different situations. One second, let me just make sure. Yeah, okay. All right. So, we haven't really specifically said it. Actually, let's work with this one first. So we have cosine squared x minus 2. So, we're trying to get the x alone. So I'm going to add 2 to both sides. So cosine squared of x equals 2. I want to get rid of that squared. So I take the square root. Cosine of x equals plus or minus the square root of 2. Okay, remember we have to do the plus or minus when we do the square root. So now, okay, so now we can solve both of these. So cotangent of x equals 0, that's a little tricky because we don't have a direct cotangent inverse, right? If you look at your calculator, we have inverse tangent, but there's no inverse cotangent. Actually, let me see real quick. I don't think there is. No. No, I don't want to take up too much time. Okay. So one thing you can do is you can look at the graph. Right. So again, you'd probably have to use, a web-based graphing calculator. You can't just type this into, your phone. So you have Desmos. Okay. We use that a lot. So I'm going to type in cotangent of x. And now we're looking for where does this equal 0? Well, we have a lot of spots that equal 0, but always look for the most simple. So over here, this would probably be the most simple answer. So when x is pi over 2, the cotangent is 0. Right. So from cotangent of x equals 0, I get x equals pi over 2. Right, but that's not my only answer. I have to add to that. Okay, tangent's period is pi, so I'm going to add to that pi times n. Right, and that's the general solution there. So that's for cotangent. Now this, we encounter a slight problem that we haven't really seen before. Cosine of x equals positive or negative root 2. If I calculate root 2, I don't know what it is exactly, but I know it's like 1.7 or 1.17. I forget. Hold on. Let me just see real quick. Oh, 1.4. That was all. Okay. The square root of 2 is 1.414. So this is telling me if I take the cosine of some angle, it's going to get me 1.414. But with our basic rules of cosine and sine, we know that the range of cosine has to be in between -1 and +1. The square root of 2, whether it's positive or negative, falls outside of that range. So if you typed in, right, even if you went to go and solve this with your calculator, right, if I plugged in cosine or inverse cosine of the square root of 2, we get an error because it does not fit in the domain of the inverse cosine. So with this, okay, we get no solution. But be careful. That doesn't mean the final equation doesn't have a solution. We already found out half of it. And that happens to be our only solution. Okay, so pi over 2 plus pi n. And again, this is known as the general form. All right, so we may use factoring as a tool to help us solve. Let's do one more with this. All right, this one's a little more, nothing fancy going on. We have sine squared x equals 2 sine x. So again, right, we see sine squared x. I can use an identity to say that it's 1 minus cosine squared, but that's not going to help me actually solve it. Right, so again, let's use our move everything with an x to one side. So I can subtract 2 sine x from both sides. So I get sine squared minus 2 sine x equals 0. Okay. All right. So here, both of those, they share a sine, a factor of sine. So we pull that out. And then I'm left with sine of x minus 2 equals 0. We can split these up now. Sine of x equals 0. Sine of x minus 2 equals 0. This one here, we have a lot of answers. Okay, I know x equals 0. That doesn't really help me. So what else does it equal? So this one is actually pretty interesting, and we'll come back to this because we have some interesting answers. Pi, 2 pi. Here we encounter a similar problem. I get sine of x is equal to 2. Okay, so that's going to give us no solution. Now this one is a little interesting because if we just look at our basic equation, sine of x, if I use the rule for my general solution before and I added 2 pi, I'd have 0 and then 2 pi and then 4 pi, but I'm missing out on all of my odd pi factors. Pi, I have 3 pi, I have 5 pi. So here we encounter something a little different, which is going to change the general form. And if I keep going down, I can see that it's at every whole number pi, right? 5 pi, 6 pi, 7 pi, 8 pi, so on and so forth. So for my solution for this, I'm just going to say x is equal to pi times n. Okay, you can switch it around too. You can say n pi. Either way is okay. All right, so be careful sometimes, looking at the graph always helps. And then also, too, you can graph both equations, right? I can graph sine squared and then 2 sine of x, and I can check those answers. So I'll do sine of x squared and then 2 sine of x. All right, so I'm looking for where do they intersect? Well, they intersect at 0. They intersect at pi. They intersect at 2 pi, 3 pi, 4 pi. And you can see the solution there as well. All right. So the last thing that I want to talk to you about, and I'm just going to introduce it now, and then we'll expand on it a little tomorrow. Because I can factor with trig, we can also have equations of the quadratic type, as we call them. So if I had something like 2 sine, yeah, we could do that. 2 sine squared x minus sine x minus 1 equals 0. All right, so, with what we've been doing, with what we've just been doing, if I add 1 to both sides, then I can factor out a sine. But then we can't do this special rule because it's not equal to 0. Okay, I can only do this rule where I split my answers up and have them equal to 0 is if it is equal to 0. Okay, if it's equal to 1 or 5 or 10 or negative 50, I can't split it up like this. Okay, I can't say that this is equivalent to this. Right? This is a special rule because going back to algebra, if you're multiplying 2 things and they equal 0, well, then one of them has to be 0. Right? If I'm multiplying 2 things and it equals 1, they could be anything. This could be 5 and this could be 1/5. This could be, it's neither of these have to be 1. So with this, I can't use straight up factoring. Okay, and we can't use the method that we just learned about. But what we can do is treat it like a quadratic. Now, it might be difficult to see. I understand that because we're dealing with sines and cosines and other things other than just x's and y's. So I would recommend doing a little substitution to get you familiar with it. So I can say that sine of x is y, right? I'm just choosing some letter y. So this I can rewrite as 2y squared minus y minus 1, right? And now I'm just looking to factor this. Well, the only thing that multiplies to 2 is 2 and 1. The only thing that multiplies to 1 is 1 and 1. This is negative, so it's going to change sign. One of them is going to be positive, one's going to be negative. And this one is negative, so that means I want my 2y to be negative. And then I just go back in and I resubstitute. Right, so I can go straight from here to this. So I can say that 2 sine squared of x minus sine of x minus 1 equals these two separate. And because they're both equal to 0, then I can split them up. I don't need the parentheses there. And I go about solving those like I just did. All right, we'll finish this tomorrow. I'll go through the final steps of that tomorrow. All right, so I am going to give you a little homework tonight. I'm going to ask you to solve a problem like this, where you go through the steps. Be careful. You may have no solution. You may have a solution. So you may have more than one answer. That's not, that's in general form. And I may give you one where I just ask you to factor. Okay, I'm not asking you to solve. I'll just give you a situation, and I'd like you to factor it out. All right, so keep an eye out for that. That'll go up a little later today. All right, guys. Any questions?
No questions.
All right. Have a great day then, and I'll see everybody tomorrow.
All right, bye, Mr. Murray.
Bye-bye.